Hello everyone, my name is Smriti Tuteja and my today's topic is quadrilaterals. So what are quadrilaterals? Quadrilateral is a four-sided closed figure. It is made up using only line segments. There are many types of quadrilaterals. Parallelogram are classified as square, rectangle, trapezium. A parallelogram is a quadrilateral which has two pair of parallel sides or even one pair of parallel sides. Kite is a figure whose adjacent sides are equal to each other and the opposite angles are also equal. So when we talk about parallelogram, in it opposite sides are equal and parallel and opposite angles are also equal. In a square, all angles are equal to 90 degrees and all sides are also equal. The diagonals of square bisect each other at 90 degrees. But the diagonals of parallelogram only bisect each other, they don't bisect at 90 degrees. Same for rectangle. Rectangle has all angles equal to 90 degrees. Opposite sides of rectangle are equal and parallel, whereas the diagonals bisect each other at 90 degrees. So when we talk about rhombus, the diagonals of rhombus also bisect at 90 degrees. But in rhombus, only the opposite angles are equal to each other. All sides of rhombus are also equal. And for kite, I have already told. The diagonals of parallelogram bisected into two congruent triangles. So for instance, let's take an example of this diagonal. In it, diagonals are AC and BD. So I am taking these two triangles . So it is given in the figure that AB is equals to BD and opposite angles A is equals to angle C and angle B is equals to angle D. What we have to prove is that triangle ABD is congruent to triangle BCD. To prove this, we will use a congruency theory, which is that angle 1 here is equals to angle 2 here and angle 3 is equals to angle 4. Angle 1 is equals to angle 2 due to alternate interior angles property. BD is equals to BD as it's common, and again angle 3 is equals to angle 4 using alternate interior angles property. This proves that triangle ABD is congruent to triangle BCD using angle side angle rule. Now let's talk about the midpoint theorem. This theorem states that if a line is joined to the midpoints of two two adjacent sides of a triangle, then it is parallel to the third side and it is half of the third side. For instance, let's take an example of this triangle. The midpoints of this triangle are AC's midpoint is E and AB's midpoint is F. If we join E and F, it states that the EF is equals to half of BC and is parallel to BC. To prove that, we'll construct a line from C, and if joined through F, it will be parallel to FB. Now we have to prove that this triangle is congruent to this triangle. Since F is the midpoint of A and of AB, AF will be equals to FB. So in triangle DCE and triangle AFE, we can say that this angle 1 right here is equals to angle 2 using vertically opposite angles property, and this is equals to this, as E is the midpoint. AE is equals to EC since E is midpoint. And we can say that angle 3 is equals to angle 4 since it forms alternate interior angles. This proves that triangle DCE is congruent to triangle AFE. Now by CPCT, we can say that this line is equals to this line, DC is equals to AF, and AF is already equals to AB as F is the midpoint. So we classify this as equation 1 and this as equation 2. So using 1 and 2, we can say that DC is equals to AF, which is equals to AB. So when we constructed this line over here, we already said that DC is parallel to FB, and now DC is also equal to AB. We can say that DC is equal to FB and DC is parallel to FB. Now this gets us here one parallelogram. And now this is proof that when we join two midpoints, we get the lines parallel, and we can also say that FE is half of AC. Now I'm gonna stop my topic here. So thank you and have a nice day.